You're welcome to this channel. If this is your first time of coming across this channel, kindly subscribe to this channel and click on the notification icon to get notified when we release videos like this. What are we learning in this video? This video is a continuation of the former one, which is carbon-based chemistry. Now, in the former video, we have talked about the crystalline allotropes of carbon. Now, we are learning amorphous allotropes of carbon. So, if you haven't watched the former video, kindly watch it. Then you come back to this video and watch it. Or after you finish watching this video, go and watch the previous one on carbon. Without further ado, let's go straight to the business. Learning amorphous carbon. The first amorphous carbon we are going to talk about is bituminous coal. Now you see this coal, this can be mined naturally. So this one, we can see it naturally. You just mine it. Those ones that are miners, they used to mine this because these are natural resources. Now this coal serves as a source of natural fuel because when you burn it, it gives out energy, heat energy, just like charcoal. It's not charcoal, it's like rock, coal, bituminous coal. Now this bituminous coal, we can perform a process on it to get another type. Now that process is called destructive distillation. So when you heat up this coal in order to do away with the volatile compound that is with coal. You see, when we mine coal, coal is going to be bituminous in nature. So which means that we are going to have some volatile compound in carbon with it. So in order to remove those volatile compound, we are going to do what is known as destructive distillation. Let me explain destructive distillation for you. Destructive distillation simply means you are eating something up in order to do away with the volatile compound. When you heat something up, the limited supply of air, that is known as destructive distillation. So when you do that for coal, you are going to get coke, another type of carbon, which is called coke. It is not the coke that we use to drink coal. Coke is still like this, but all the volatile compound inside bituminous coal has been vaporized. So you are left with coke, which is still pure form of carbon. It is not 100% pure, but we now have coke. Now we have coal tar again. Coal tar is a liquid. Then we are going to have coal gas. Then we have another liquid which is known as ammonia liquor. So destructive distillation of coal, what are you going to get? You are going to get a solid that is known as coke. You are going to get a liquid that is known as coal tar, another liquid that is known as ammonia liquor. Then you are going to get a gas, some gases which are called coal gas. For coke, we can use coke as a reducing agent in blast furnace. So we used to use coke to reduce iron ore. So this is one application of coke. Coke also serves as a pure form of energy, heat energy. You see, the olden days train, they used to use this coke to power train. Now, in the generation of energy in the olden days, combustion engine, we used to use coal and coke. Now we have coal tar. Now coal tar is very dark. And if you have seen when they are doing construction of road, now after they have poured the asphalt, you see that they are going to pour one black liquid on the road like this. That black liquid is called pitches. Now it is coal tar in construction, and we can also use it as binder. Now you see this binder are substances that hold other materials together, other substances together. So that is why after they have poured the asphalt on the road, they still need another binder. So coal tar is also serving as a binder. So that is function of coal tar. Then we have coal gas. Now coal gas can be used as industrial fuel. Coal gas, we have maintained inside coal gas. We have a lot of gases inside coal gas. So coal gas can be used as industrial fuel. Then we have ammonia liquor. Now ammonia liquor can serve as a source of nitrogen compounds which can be used to make fertilizers. So ammonia liquor is very rich in nitrogen compound and it can be used for making fertilizer. So let's quickly do a recap. When we have destructive distillation of coal, what are we going to have? Coke, coal tar, coal gas, ammonia, liquor. Which one of these can serve as a source of fertilizer, nitrogenous compound? We have ammonia. So which one can be used as industrial fuel? We have coal gas. Which one can also be used as energy? Source of energy, we have coal. And reducing agents, coal. Then coal tar can be used for making pitches, black pitches, for construction and binders. Now let's look at this coke, which is amorphous carbon. For this coke, we can also use coke to get some fuel and some gases. Now, how do you do that? When you burn coke, you heat it up and you supply either steam or you supply air. Don't forget that steam is a water. Steam, vaporized water. When you heat up coke, you supply it, then you now pass air or you pass steam over it. You can get some gases. So that is what we want to look at. Now, this coke, we can get two gases from coke. The first one is producer gas. How do we get producer gas? Now, the method of production of producer gas is you pass hot air over red hot coke. So let's say you have in a compartment or you have a chamber and you heat up coke to the point at which it is red hot. And when air is passed over it, we are going to get gas that is known as producer gas. Now, producer gas consists of carbon monoxide, nitrogen, and hydrogen. And it can be used as fuel. They can be used as what? As fuel. Now, another gas that you can get is water gas. How do you get water gas? When you pass hot steam over white hot coke. When you heat up coke to the point at which it is white hot and hot steam is passed over it, you are going to get a gas that is known as water gas. For water gas, the constituent is we have carbon monoxide and hydrogen with little or no nitrogen. So the constituent of water gas is basically carbon monoxide and hydrogen. It also serves as fuel. It also serves as what? As fuel. Now, between producer gas and water gas, which one has much energy? Which one has much energy? Now, it is water gas. Now, let's look at the process, which is called gasification of coke. How can we make producer gas and water gas? Now, this is a compartment. Now, in this compartment, coke will be deposited like this, and it will be heated here. Now, when air is now allowed to pass through this orifice, producer gas will be produced. We have a producer gas coming out here. When steam is allowed to pass through this, water gas will be produced. Please master this diagram very well. Can you see this diagram? When air is passed in here, producer gas is being produced here. When steam is passed here, water gas is produced here. Look at all coke being supplied here. Heat being supplied here. If they now put steam here, what will be the thing that will come out here? That is water gas. Now, another amorphous carbon which we are going to talk about is known as charcoal. In my language, we used to call it edu charcoal. Now, recall that the first amorphous carbon that we talked about here is coal. Abi, now look at this. We now have char and coal. So which means char will have a meaning. Now, let me explain char for you. Char is from charing. Charing. When you char something, it means that you are supplying it to that thing with limited supply of air. That is what we call charring. Now, when you char wood, you are performing a process that is known as charring of wood. You are going to get charcoal. Charcoal is one of the things that you are going to get in charring of wood. So how is charcoal being made? When you have wood and you heat it up. You supply it to it with limited supply of air. Locally, this is how they used to make charcoal. They are going to cut down woods. When they cut down tree, they will now burn the tree inside the ground so that air will be minimal. There will not be supply of oxygen. That is what we call charring. Now, in this process, we are forming carbon, pure form of carbon, because you are removing the volatile compound from the wood. Now, it is known as artificial made coal. Charcoal is artificial made coal, and we have different types of charcoal. The first one is we have wood charcoal. Oh yeah, what is wood charcoal? This one is formed by what? By charring of wood. When you heat up wood with limited supply of air, that is how wood charcoal is being formed. You don't know charcoal, I believe you all know charcoal. You are not butter. Even if you are butter, you have seen charcoal before. This is charcoal. Charcoal here. You see? Now, what are the uses of charcoal? Charcoal has many uses. Charcoal can be used as source of energy for heating, for cooking, isn't it? Yeah. Apart from cooking, you see this charcoal here? It is a raw material for making what is known as activated carbon. Activated carbon. You see, activated carbon can be used to trap gases, to trap poisonous gases. Now, it does so by a process that is known as adsorption, not absorption. No. Adsorption is the process by which gases are trapped on the surface. We can use wood charcoal to form activated charcoal. Activated charcoal is formed when charcoal is being heated up and then some gases has been infused inside the charcoal in order to increase the surface area of that charcoal. So that is that about wood charcoal. We also have animal charcoal. Now, animal charcoal is formed when we char bones of animal. You see bones, when you heat them up, you supply it with limited supply of air, you are going to get something like this. This is what is known as animal charcoal. Animal charcoal is also pure carbon, and it can also be used for what? For making activated charcoal as well. If someone accidentally eats poison, and we can use activated carbon, that person can ingest activated carbon because activated carbon can trap poisons. I'm not telling you to go and grind charcoal and be eating it. Activated carbon, they are treated carbon. Now, we also have another charcoal that is known as sugar charcoal. Sugar charcoal. This is sugar charcoal. Can you see it? Sugar charcoal is a form of carbon, and it is the purest form of amorphous carbon, something that contains almost 100% carbon. So sugar charcoal is the purest form of what? Amorphous carbon. Now, for sugar charcoal, how is it being made? Now, this is made by dehydration of sugar. When you have pure sugar and tetrasulfuric acid is being used as a dehydrating agent, and when you supply H2SO4, you pour it to sugar, the H2SO4 will absorb. You know, H2SO4 is dehydrating agent. It absorbs water. Now it's going to absorb all the H2O inside sugar. Remember the formula for sugar now? The formula for sugar we have COH2X-OX. Now the H2O inside sugar, H2SO4 is going to absorb everything, and you'll be left with pure carbon like this. This is called sugar charcoal. Now to the use of sugar charcoal. You see this sugar charcoal, since it is a pure form of amorphous carbon, we can use it to form or to make an artificial diamond by heating it up at an extreme high temperature, 3000 degrees Celsius and above. When you heat it up, you are going to form an artificial diamond. Now, this same sugar charcoal can be used as a reducing agent in the extraction of iron to reduce iron ore. Sugar charcoal can also be used as a decolorizer. We can use it for decolorization. So you can use it for decolorizing dyes, ink, petroleum jelly, and the likes. Now, destructive distillation of wood, as I've explained, we are going to get wood gas, wood tar, pyroligneous liquor, and charcoal. Now, let's look at wood gas. Wood gas simply consists of carbon 4 oxide, carbon monoxide, methane, and hydrogen. All these gases are found in wood gas and they can be used for heating. Source of energy. Now we have wood tar. Now wood tar consists of phenolic compound and it can be used for making rubber softening agent. Now, example of phenolic compound is medicinal kraut. Medicinal kraut. Now it can also be used for softening of rubber. This wood tar. Now you see this wood tar, it consists of many compounds, many chemicals inside wood tar. Now we also have Pyroligneous NECO. Now you see the deodorizer soap that we used to buy. Deodorant, the soap for bathing. Now there is something inside Pyroligneous liquor which is methanol. Methanol is spirit. We call it spirit. Methanol is spirit. And it is found in Pyroligneous liquor. Now you see that methanol can be used for making disinfectants. Example of disinfectant is what we call spirit for treating of wound. So Pyroligneous liquor consists of that. It also has water and it can also be used for deodorizing in our perfume, in soap, deodorizer, we use it as well. Now, which is known as insecticide. We can also use it for making insecticide. So Pyroligneous liquor. Now, finally, we have charcoal. Now, charcoal is a raw material for activated carbon. It can also be used for making fuel as a source of energy. Fuel. Another amorphous carbon is known as carbon black or carbon soot. Carbon black or carbon soot. Now you see carbon black or carbon soot, it is form of carbon. This one is not pure. This one is formed by incomplete combustion of fuel. Incomplete combustion of fuel. The black substance that is being produced, when you gather it up, it is known as carbon soot. Now, where can we find carbon soot? Let me show you something. Locally, we can find carbon soot by burning fuel like palm oil. We used to call it atupa. Now, it's going to be bringing out some dark fumes. So, if you collect those dark fumes is known as carbon soot. Another one is, if I could remember, during the days we used to use stove. Yeah, we have some stove that will be bringing out black substance. Now, those black substances are known as carbon soot. Carbon soot, incomplete combustion of fuel or carbon-based compound. The dark stuff, when you gather it, you get a powder, which is known as carbon soot. Now, this carbon soot, what are the uses of carbon soot? Now, carbon soot can be used in making tire reinforcement. In the process of making tire, carbon soot is employed in order to increase the strength of a tire and also increase the toughness of tire. Now, let me quickly say this in organic chemistry. We have what is known as what? Vulcanization, isn't it? To increase the what? Okay, we are not going there. Now, tire reinforcement increase the toughness of tire and the strength of tire. Now, you see this black stuff, which is known as carbon soot. They are used as in paint for black pigment. They use it in what? In paint. So when you see any black paint, know that inside this black paint, there is carbon soot there. Another one is black shoe polish. Black shoe polish. Carbon soot is also used for making black shoe polish. Okay? Now, let's talk about the oxide of carbon, the basic oxide of carbon. The first one is carbon 4 oxide, also known as CO2, carbon 4 oxide. Now, carbon 4 oxide is a gas that is important for plants, for the growth and development of plants. And if we are talking about the gas that we are exhaling, we are breathing out, it is CO2, carbon 4 oxide. Now, how do we prepare carbon 4 oxide in laboratory? when you pour HCl to CaCO3, that is calcium carbonate, calcium trioxocarbonate, chalk. And when you pour acid, ACl, as carbon dioxide will be given off. Now, how do you collect carbon dioxide in laboratory in this process? You collect it by what? Downward delivery, because carbon dioxide is denser than air. So we have downward delivery, or you can also collect it over water. All right, the drying agent for carbon dioxide is calcium chloride or concentrated H2SO4. Drying agent is when you want to remove water from gases. Now, you can employ calcium chloride or H2SO4. Now, the test for carbon dioxide is that it turns lime water into cloudy or milky solution. Carbon dioxide turns what? Lime water into cloudy or milky solution. One of the uses of carbon dioxide is it can be used for making fire extinguisher. Now, you see, CO2, it doesn't support combustion. So that is why it is very useful for making fire extinguisher. Now, it can also serve as a refrigerant, dry ice. They are known as solid refrigerants for cooling. In all our soft drinks, all these carbonated drinks, now we have carbon dioxide inside it. You see the gas after we have drank our Coke, Pepsi, Mirinda. Now the gas that we used to guff out, or when we open our drinks and the gases that used to come out, it is carbon dioxide. So which give us some kind of refreshment. Laboratory preparation of carbon dioxide or carbon dioxide. Now this is the setup here. Okay. Now here we are going to pour HCl and we can open this. Now inside this place we are going to have calcium carbonate, chalk, CaCO3 here. Now after that the reaction will start. Now this is the reaction, HCl plus CaCO3. We are going to get calcium chloride plus water plus CO2. So which means that we need to what? To dehydrate CO2 to use a drying agent. Now this is the delivery tool. You can see that we have downward delivery, and this setup is known as BF shape. This one is straw. So we have water and we have glass jar, so we can collect our carbon dioxide here. Laboratory test for carbon dioxide. How do you test for carbon dioxide? I think I've explained it. Let me just show you. Now you have lime water, Ca, calcium hydroxide, which is colorless. Now you are going to pass the gas inside lime water. Once you pass the gas inside lime water like this, and that lime water turns to milky or chalky or cloudy solution or precipitate, it means that CO2 has been confirmed. So this is what I'm telling you. Now when you pass CO2 inside this solution, calcium hydroxide plus CO2, you are going to get calcium carbonate, chalk, as precipitate plus water. So it is now going to be cloudy or milky. So that is the test for carbon dioxide, which means that it turns lime water. Lime water simply means calcium hydroxide. It turns to milky or cloudy. So now another oxide of carbon is we have carbon dioxide, poisonous gas. You see this carbon monoxide is very poisonous. When you inhale it, this is what is going to be happening. It's going to be binding up with your blood, hemoglobin. We now have carboxyhemoglobin instead of having oxyhemoglobin. You see, oxygen binds with the blood when we are breathing in. Now, carbon monoxide will now replace oxygen, will now be binding with your blood. So oxygen will not bind with your blood, and oxygen will not be supplied to your brain. After a while, that person is going to collapse and die. So that is why we need to be careful when it comes to carbon dioxide. So in some ways, you just hear that some people die when they on generator, they put it inside the room, and then after some minutes in the morning, there is foam coming out of their mouth and they all died. It's because of all these gases. Carbon monoxide can be formed by incomplete combustion of carbon-based compound. So when you are supposed to use anything that is carbon-based and you are burning it, please, for God's sake, make sure that that place is well ventilated. Don't run your generator and put your generator inside the room. Put it outside. Don't on your charcoal. Don't light up your charcoal pot and you put it inside one corner of your room and you are cooking. It is very dangerous. Incomplete combustion of carbon will produce carbon monoxide and you start inhaling it and gradually you are killing yourself. Now, carbon oxide is combustible. It is combustible. It can be used as fuel, carbon monoxide. Now, method of preparation, we have this oxalic acid plus metanic acid or oxalic acid, anyone, plus H2SO4, this guy. So carbon monoxide will be produced. How do we collect it? It is lighter than air, slightly lighter than air, or less dense than air, so we can collect it by upward delivery. The drying agent is also the same thing with the drying agent of carbon oxide. Now the test. Now this one has many tests. It turns black copper 2 oxide into reddish brown. It also turns palladium chloride paper to black. One of the uses of carbon oxide is it is used in the making or production of iron as reducing agent in metallurgy. Now let's look at the laboratory preparation of carbon monoxide, CO. This is a laboratory preparation. This is a setup. So we have H2SO4 will be poured like this. Now we have oxalic acid here, or metanic acid, anyone. Now this is the reaction COOH plus H2SO4. Now after you have done this, you are going to eat this for reaction to take place. Don't forget that it increase the rate of chemical reaction. Two things will be produced here. One of the gases that will be produced is carbon oxide and carbon monoxide. The two of them will be produced. So which means that we need to take care of carbon oxide. So here, that is why we have this setup here. This setup is sodium hydroxide. Now sodium hydroxide will absorb the carbon oxide. So this is the reaction here. It's going to absorb the carbon oxide to form sodium carbonate and water. Then your carbon monoxide will now pass. So you can now collect it over this setup. Carbon monoxide is collected by what we know as upward delivery, downward displacement of air. Test for carbon monoxide. We have this reaction. It turns palladium chloride to black. You also have this. It turns starch solution to, let me explain this. This one is iodine pentaoxide. Iodine pentaoxide. Now, carbon monoxide is going to, like when you react it with iodine pentaoxide, you are going to get iodine. And that iodine, when you treat it with starch, it's going to turn starch solution to black. This one is just like a test for starch. So which means that CO is going to reduce iodine pentaoxide to iodine. It's a reducing agent. You see this CO is a what? Is a reducing agent, not oxidizing agent. Reducing agent. Now this CO will also reduce copper 2 oxide to copper, and that is why it is used in metallurgy. Now black CuO turns to reddish brown. That is a test for carbon monoxide. Finally, let's look at inorganic compound of carbon. Let's talk about just one, which is carbonate. Chalk carbonate. Calcium carbonate. Let's talk about calcium carbonate or calcium triosocarbonate 4. It's TaCO3, which is known as chalk. Calcium carbonate chalk. Now you see this one, we can find it naturally because it is formed by sedimentary rock. This one is sedimentary rock. So this is calcium triosocarbonate. Now, calcium triosocarbonate has a lot of uses. We use it in making cement. It's one of the components of cement, binder cement. It's also used in making of glass. One of the important components of glass. calcium trioxocarbonate. Chalk is also part of it. Now, it also has a lot of use in medicine and the like. So now we have learned everything about carbon now to some extent. In this video, we're able to talk about the amorphous carbon. The purest one is what? Sugar charcoal. Sugar charcoal. We talked about coal, which is natural. It can be used as fuel, and we can get a lot of compound, a lot of chemicals from coal when we destroy it. Destructive distillation. Now, we also talked about destructive distillation of wood, that we can get some compound there. We can also get amorphous carbon, which is wood charcoal. Wood charcoal. We talked about different type of charcoal. We talked about wood charcoal from wood, destructive distillation of wood or charring of wood. We talked about animal charcoal, destructive distillation of bones, which is known as charring of bone. We also talked about sugar charcoal, which is dehydration of sugar by adding H2SO4, and that carbon that is being formed is known as the purest form of amorphous carbon. Now, I talked about activated charcoal, isn't it? Activated charcoal is formed when you heat up charcoal and you infuse some gases inside it in order to increase the surface area for adsorption. Adsorption is different from absorption. Adsorption is when gases are trapped on the surface. Now, we also talked about carbon monoxide, poisonous gas. Carbon dioxide, very useful. Carbon dioxide, the test for carbon dioxide is it turns lime water to milky solution. Carbon dioxide is used as refreshment in carbonated drinks. It can be used for what? For making fire extinguisher, because it doesn't support combustion. Talk about carbon monoxide, that one, and poisonous gas. It combines with the blood to form carboxyhemoglobin. It is used in metallurgy. It is used in what? Metallurgy. We also talked about carbonate. Talked about just one, which is what? Calcium carbonate, CaCO3, and it uses. Alright, thank you. Now, in the next video, we'll now start organic chemistry properly. We are going to look at organic chemistry. Make sure you like this video. Give this video a thumbs up. Comment in the comment section. What have you learned in this video? I need your comments. I need your like. Thank you. See you in the next video. Bye for now.